Hey, welcome back. And today we are going to continue to talk about functions and how we kind of evaluate them. In addition, we're going to add, subtract, and multiply today. And then we're also going to have to look at compositions and what that is. So go ahead, and to start off, we're going to be adding, which you guys know is when we combine our like terms. Okay. So when I say adding, today we're going to add our functions. So we're going to combine the like terms between the two functions. So in our case here, we have f plus g of x. What that means is we take f of x and g of x, and we're going to add those two together. So let's start by writing f of x, and I'll put it in parentheses here. So we have our 2x minus 7. Then we're going to add that with whatever g of x is, which in our case here is 8x plus 3. So we can just combine those like terms. The 2 plus the 8 gives us 10x. And the negative 7 plus the 3, oops, let me erase that, will give us a negative 4. And after that, we're done. We got our answer. Now, on this one, if it had been g plus f of x, it's going to be the exact same thing. If we flip those around and we're adding, it does not change a thing. Now, our next one, subtracting. To do this, we're going to start off by writing it exactly the same way. Okay, so put our parentheses around 2x minus 7. Now we're going to subtract g of x, which in our case is 8x plus 3. But here, we have to distribute that negative in. Okay, so distribute the negative. I'm going to write that over here for our instructions for subtracting. So distribute that negative. And once we distribute the negative, we're still going to have 2x minus 7. It'll be negative 8x minus 3. So 2 minus 8x then gives us negative 6x. Negative 7 minus 3 minus 10. And that right there is our final answer. Now, something to note, if we had flipped that around and it was g of f of x, the negative would be distributed onto here. It will change our answer, okay? It will cause some of the signs to change. So now, f times g of x, okay? So this time we're multiplying, so we're going to either have to distribute or FOIL depending on the problem. So we want to start off, let's write it exactly the same way as we did up here, except there will be a multiplication in the middle. Okay, so we can do that as 2x minus 7 times 8x plus 3. So we're multiplying those, and in this case, since we have two terms on both of them, we're going to want to FOIL. So we start with our first. 2x times 8x gives us 16x squared. O for outside, 2x times 3, so that'll be plus 6x. I for inside, that gives us negative 56x. And then L for last, minus 21. Okay, at this point, we're just about done. We just got to go through and combine our like terms. So our final answer is still 16x squared. It's going to be minus 50x minus 21. All right, and then we're done. So the final one now, the way we read this, it's f of g of x. So what I mean by that is we plug in this g in place of the f. So f of g of x, we plug in one of the functions to the other. Okay, so plug in one function to another. So in our case here, f of g of x, since the f comes first, that's the one we're plugging it into. So we start, since f comes first, we go up here to f, and we start with the 2. So we're going to do 2. Then anytime we get to an x, so in our case 2 times x, so in our case we'll put parentheses, and now we put the g, we plug the whole function in there. So 2 times 8x plus 3, close the parentheses, and then minus 7 at the end. Okay, so now we go ahead and we solve it just like a normal problem. We're going to distribute that 2 in, 16x plus 6, all that minus 7. And our final answer here, we'll combine our like terms, we'll get 16x minus 1. And we are done. So the next one, same approach, except now, instead of the f coming first, they have g of f of x. Also, we're using two different functions here provided. So g of f of x, that means we start with the g. So let's go over here, and we'll start with our 3. Put your parentheses, and instead of the x, we plug in whatever f of x is. So in our case here, 5x squared plus 2. We close the parentheses, and then it's minus 4. And we got that from the g. So okay, now distribute this 3 in. We're left with 15x squared plus 6 minus 4. We're almost done. Just combine our like terms. 15x squared plus 2 is what we'll get. 6 minus 4 gives us 2. And we are done. Now, I want to show you g of f of x. That's where we start with g and plug the f in. Here is f of g of x. This is going to be a totally different answer when we start with f and we plug g into it. Okay, so follow along with me. We're going to start with f, so it'll be 5. Then in the parentheses here, we're going to do the 3x minus 4. And all of this will get squared, plus 2. So now, 3x minus 4 is the same, or if we square that, it's 3x minus 4 times 3x minus 4. So we're going to do FOIL. So first gives us 9x squared. Outside gives us minus 12x. Inside, another minus 12x. And last gives us plus 16. Okay, so we need to simplify or combine our like terms. So 9x squared minus 24x plus 16. So now let's plug that in place up here. So in our case, let me scroll down a little bit. It'll be 5 times all of that. So 9x squared minus 24x plus 16. Don't forget there's a plus 2 at the end. Okay, we're just about done. A couple more steps. Now let's distribute that 5 in. Okay, so 5 times 9x squared gives us 45x squared. 5 times negative 24 is going to give us, negative 120x. 5 times 16 gives us plus 80. And then don't forget plus 2 at the very end. And we're almost done. Now just simplify. So 45x squared minus 120x plus 82. And we are done. All right, so obviously that problem, f of g of x, was much more complicated than g of f of x. Sometimes that's the case, but make sure you always start with whichever function is at the front in the lead. So go ahead and we're going to practice a few more of these. So sometimes we're going to have compositions when there's also a number. Okay, so if we have a composition with a number, what that means is the same thing we did on the front, except then we're also going to plug that 1 in the g of x. Okay, so if I were you, I'd start, let's just plug in that 1 into the g of x. So we're starting with g of x, 4 times 1. In our case, 4 times 1 gives us 4. So now, since it's f of g of 1, we plug the 1 into g, so g of 1 gives us 4, so we can plug that into the f of x. Okay, so in our case, it'll be 2 times 4 squared minus 3. So now, 4 squared we know is 16, so 2 times 16 minus 3. 2 times 16 is 32, minus 3 results in 29. All right, our next one. g of f of 5. So same thing. Let's start by plugging that 5 in to the f. So in our case, it'll be 2 times 5 squared minus 3. 5 squared is 25, so 2 times 25 minus 3. 50 minus 3, which gives us 47. Now we take that 47 and we're going to plug it into the g. So all we have left to do is 4 times 47. So in that case, we're going to get 188. And that is our final answer. Okay, and if you can't do that stuff in your head, that's fine. Use your calculator. You all should have it pinned to the bottom. I don't mind if you use a calculator. I just want you to find the right answer. Okay. So now, the final thing, actually I guess we got two things. In this next section, same idea, except now we have 3 functions to choose from. So you only do the functions that it tells you, so f of h of 2. So the 2 we're going to start by putting into h, which in our case over here, h is x cubed. So it'll be 2 cubed. 2 times 2 is 4, times another 2 gives us 8. And now we're going to plug that into the f. So in our case, it'll be 5 times 8 minus 1. 5 times 8 is 40. 40 minus 1 gives us 39. And that is our final answer there. So now, let's do the next one. G of f of negative 3. So that negative 3 we plug into the f. So 5 times negative 3 minus 1. 5 times negative 3 is negative 15 minus 1 gives us negative 16. Okay, that negative 16 now we're going to plug into the g, which g of x is just negative x. So in our case, it'll be negative times that negative 16. Negative negative becomes positive, and our answer is just 16. Okay. So now, the final way we can do compositions is sometimes we have graphs. So if we look here, we've got 3 different graphs, each have a different label. So this first one, h of f of 1. So in our case, we're going to start with f of 1. We go to the f graph here, f of x, and we find what is the value when x is 1. So the x-axis here, x is 1. The y value right there is a 4. So I'm going to jot that down. Now, that 4 takes the place of f of 1, and we find h of 4. So we go over to h, and when it's 4, our answer is 3. So that's our final answer. And once again, you're going to have kind of like 2 answers. The answer to the first part, then the final answer. So in our case, the answer to the first part here, g of 2. We go over here, and on the g, when x is 2 right here, then y is 0. So I plug in a 0 there. Now I plug that 0 into h, so h of 0 right here has another value of 3. So these two had the same answer, totally different ways that we got it. We used different functions, got the same answer. So g of f of 2. So on this one, we can find where is f of 2. So on the x-axis, we go over to 2, and right here, the y value is 2. Now g of 2, just like the last one, g of 2 we have here, and we get 0 as our final answer. Okay, and our final one, we're just about done with today's lesson, h of f of 3. That's how we'd say that. So f of 3, we'll come over here to our graph and find when x is 3, so is the y. And then h of 3, we come over here, and when h is 3, the y is 4. And that is our final answer on that. So go ahead and make sure we try today's kind of practice of that. And if you have any questions, please let me know. Hope you guys have a great day.